Hello, my name is John Vocio, and I'm a professor of mechanical engineering here at Wentworth Institute of Technology in Boston, Massachusetts. So today I'm talking about the use of superconductivity to power electric airplanes. So for those of you not familiar with superconductors, they're materials that have been around for over 100 years, but the main power of superconductors is that you can transmit power more efficiently, and for planes it's going to enable smaller engines, which also enable better aerodynamic designs of airplanes. And why that's important for climate change is that we can minimize the emissions to the environment. So, and it's all about the efficiency of these airplanes because of the aerodynamic design. Here I'm holding in my hand a small sample, a coil of superconducting cable, and this is an insulated winding. What you can't see by simply looking at it is this is a multi-filamentary superconductor, and that's important for minimizing the so-called AC losses. So the benefit of superconductors, you can get much higher current in the same space. So maybe if this wire was copper, say, you'd be only putting in, maybe 10 amps most before it burned up. But in the superconductor, if you cool it down low enough, you can put in hundreds of amps. So that's the enabling technology to shrink the size of motors. So here in this particular lab, this is where we study the various properties of superconductors. Here behind me we have a simple test station using liquid nitrogen. We can even solidify nitrogen in this simple vacuum bell jar, and that's necessary to test this new superconductor, which is being developed in conjunction with a Massachusetts company called Solid Materials Solutions. And this material is specifically designed for superconducting applications where you need to change the magnetic field. So without going into too much detail, in a motor you have a rotating part and a stationary part. The more challenging thing is to electrify the stationary part, and that's what this new material is designed to do. So currently we have some funding from NASA Glenn in Cleveland, Ohio, to look at designs of those motors. So that's where we're at right now, is to look at specific new topologies of these motors which can be used in the future on an airplane. So some of the challenges are, funding for that futuristic development. If you're wondering how would you possibly cool these superconductors, well, that's where there's a lot of synergy with climate change. So here I'm going to take a step back and talk about wind power, because it's going to relate back to the planes, but there's lots of renewable energy wind resources, say in the Midwest. Some of that can be put on the grid, the electric grid, but the electric grid doesn't have a lot of energy, it has very little actually energy storage capacity. So one thing people are looking at is using electrolysis to make hydrogen. And why hydrogen is important, it has very high energy storage density, so it can be burned in conventional diesel turbines, including those on planes. And in fact, on planes, you'd further want to densify it by liquefying it so it could, for various reasons. And liquid hydrogen has an operating temperature of 20 Kelvin, which is minus 253 Celsius. And that essentially provides free cooling for the superconductors. So there's a very synergistic vision there. And so this material will enable that possibility. So that's where we're at. I definitely want to thank the Solar Butterfly team for coming and putting a little bit of a spotlight on this activity, and I hope this has been of interest to you.